Let F be a permutation which is formed from the set 1, 2, 3, 4, 5, 6, 7. This is the set. Have element 7 element. So degree of permutation formed from the set S will be 7. Number of element in the set is equal to the permutation, degree of permutation formed from that set. Now element of the set 1, 2, 3, 4, 5, 6, 7. Now cyclic permutation. By definition of cyclic permutation, image of one element formed on image of element of S formed on following elements, like image of 1 formed on 2, image of 2 on 3, image of 3 on 5, image of 5 on 7, image of 7 on 1. This will form a cycle, and remaining element here, remaining element 6 and 4 should be mapped on itself. Then we will call this permutation is cyclic permutation, and it is denoted by image of 1 on 2, 2 on 3, 3 on 5, 5 on 7, 7 on 1. So this is the cyclic permutation F. Both are equal, and remaining element 4 on 4, 7 on 6 on 6 not included, and length of F, cyclic permutation F. Number of element in the cycle. Length of F equal to number of element in the cycle. Number of element here 5. So length of cyclic permutation 5. Now take another example. Permutation G, which will be formed again by the set using the set this 1, 2, 3, 4, 5, 6, 7, 2, 4, 5, 5, 7, 7, 2, 3, 4, 6, 1. Now element of 1 on 1, 2 on 5, 5 on 7, this image of 2, 2 on 5, 5 on 7, 5 on 7, 7 on 2. This will form a cycle 2. Image of 2, 5, 5, 2, 5, 7, and remaining element 1, 3, 4, 6 should be remaining element mapped on itself. So this is the cyclic permutation which formed a cycle, and remaining element should be on itself, and length of G equal to number of element in the cycle 1, 2, 3. So 3. Now identity permutation. If we know about the identity permutation, then element should be formed on itself, like 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, element of 1, image of 1 or mapping of 1 on 1 1 2 on 2 3 3 4 4. This is the identity permutation, and length of this permutation should be 1, because image of 1, it can be denoted by 2, 3 or 7. Both are same, because this means image of 1 on 1, 2 on 2, 3 on 3. This can be denoted as this, and length will be 1. Now inverse of permutation. Let's take G is the permutation 1 2 3 4 5 6 7, 5 2 7 1 4 6 3. Inverse will be element of 5 on 1, upper row will be down and lower row will be above. 5 2 7 1 4 6 3. This is the lower row, upper row. Upper will be down 1 2 3 4 5 6 7. Image of 1 on 5 in inverse permutation. This is the inverse of G. Image of 5 on 1, 2 on 2, 7 on 3, 1 on 4, 4 on 5, 6 on 6, 3 on 7. It can be arranged 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. Image of 1 on 4, 2 on 2, 3 on 7, 4 on 5, 5 on 1, 6 on 6, 7 on 3. This is the inverse of G. Inverse of permutation G. Now we can also express. Now let's take this permutation F. Now we can also express this permutation into, we can also express a permutation into a disjoint cycle. What is the disjoint cycle? Disjoint cycle, a cycle, there are product of cycle in which there will be no common element, then we will call disjoint cycle. Cycles, many cycles are produced and there will be no common element, like image of 1 on 4, image of 1 on 4, 4 on 5, 5 on 1. This is the one cycle F. This is the taking this inverse as a new permutation, not connected with this. 1 4 5. This will be completed 5. Now remaining image of 2 on 2, 1. This is the identity permutation. Image of 3 on 7, 3 on 7, 7 on 3, 3 7, 6 on 6. This is the disjoint cycle. Length of this cycle is 3, length of this cycle 1, length of this cycle 2, length of this cycle 1. No common element. This is the product of disjoint cycle, which expressed from this. Both are equal. This permutation F and this permutation are equal. This permutation can be expressed as a product of disjoint cycles. And by if we know that transformation from a permutation to this product of disjoint cycle, then we can also know about the order of the permutation. Like it can also written like we can remove, because there will be no effect. It can add or remove, no problem. 1 4 5 3 7. So this is the permutation. All three permutation are same permutation. This is the permutation, and it can be expressed as a product of disjoint cycles. Disjoint cycles means a combination of cycles in which no element should be common. No common element. And if we know the length of disjoint cycle, this length 3 and length of this cycle 2. Now order of the F will be LCM of 2 and 3 equal to 6. So order of this permutation 6 6 6. Now please revise. We have learned about cyclic permutation, in which image of element followed and remaining element followed cycle or form cycle, and remaining element should be mapped on itself. And identity permutation, where element formed image on itself. Inverse permutation. In inverse permutation, lower row will be go down and lower row will go above, and upper row will go down in inverse row, like this. This is the inverse of this. And now if length of cycle will be 2, then we will call them transposition. Like a permutation G 1 2 means 1 2 elements of 1 on 2, 2 on 1. This is called transposition, and we can transform any cycle into a product of transformation. Like a cycle taken 1 4 5 7, image of 1 on 4, 4 on 5, 5 on 7, 7 on 1. It can be transformed into a product of transposition in 1 to 4, 1 transposition, 1 to 4, 1 to 5, 1 to 7. This is the product of 3 transposition, and both are equal. This cycle can be transformed into a transposition length 2. If you multiplied this permutation, you will get this result. And length of this cycle 2. This is the called transposition and product of transposition. Here number of transposition is 3, which is odd. Then F called odd permutation. Number of transposition will be even, then F will be called even permutation. Order. For order, let F is a given 1 2 3 4 5 6 7 8 9, 2 3 1 4 6 7 8 9 5. This given permutation can be expressed as a product of cycle, disjoint cycle, elements of 1 on 2, 2 on 3, image of 4 on 4. This is the identity permutation, because image of elements formed on itself, identity permutation. And image of 5 on 6, 6 on 7, 7 on 8, 8 on 5, 8 on 9. This is the product of disjoint cycle. You can remove identity permutation. Identity permutation you can write 1 4 4 1, no problem. Elements of 1 on 4, 4 on 1. If you multiplied, you will get identity permutation. 1 elements of 1 on 4, 4 on 1, 1 elements of 4 on 1, 4. Oh, sorry, 1 on 1, 4 on 4. This is the identity permutation. So you can write this way. So you can remove, no problem. 5 6 7 8 9. Length of this permutation is 3. Length of this permutation, cyclic permutation, 5. Now order of F equal to LCM of 3 and 5 equal to 5 into 3, 15. You can also multiply this permutation and form a permutation 1 2 3. You can form this permutation. Okay, so let's LCM. You can transform F 1 2 3, write this 5 6 7 8 9. You can transform this permutation into a combination of transposition. This can be transposed 1 2 1 3. A way of writing transposition. This is the cycle. So write 1 2 1 2 1 3. You can write in many way, but remember one way: first element, second element, first and next element, first and next element. This is the transposition, combination of transposition. This is the combination 5 6 first element, next element 5 7 5 8 5 9. So total permutation 1 2 3 4 5 6 6, which is the even. So F is the even permutation, F even permutation. In this lecture you know about in this lecture I have completed permutation, identity permutation, inverse permutation, cyclic permutation, length of cyclic permutation, order of permutation, order formula, express given permutation into a disjoint cycle and get order by LCM of length of disjoint cycle, and even odd permutation, expressed given permutation into a transposition form, and calculate number of transposition. If number of transposition will be even, then given permutation will be even, and if number of transposition will be odd, then given permutation will be odd. If odd, then odd. Even, then even. That's all. Thanks.